world is full of unsolved problems that are too big to answer, like world hunger, pollution, climate change, homelessness, food shortages, poverty, inequality, and the energy crisis. But what if we could? One problem at a time. One person can only do so much in their lifetime, and we get caught up in our work and home lives that we tend to ignore the problems that are not immediately in front of us. But everyone can do their part on a small scale with eco-art. Eco-art is a way to generate energy by using an interactive art installation to conduct electricity and store it for later use. So basically, you can make electricity by releasing stress with punches. Once hit, the cactus will move back and forth, creating electricity with polarized dielectric material, and will force it into the battery to store the power. This power can be used for the grid or be used as a generator to power something in your home or office. These interactive art pieces can be strategically placed so they can generate the greatest amount of energy possible. Everyone wants to make the world a better place, including us at EcoArt. So just remember, when you see EcoArt, do your part.
Hello, we are EEM3 and our product is EcoArt. My name is Veronica Garola. I'm a mechanical and aerospace engineer.
I'm Nikki Trujillo and I'm getting my master's in mechanical engineering.
I'm Carson Anderson and I'm an electrical engineering student.
I'm Veronica Trujillo and I'm an electrical engineering student.
And I'm Chase Austin and I'm getting my master's in mechanical engineering.
And our product utilizes the Triboelectric Effect to generate energy through interactive art. So we chose need statement number 8, which is utilizing and storing untapped energy generated in homes and offices to increase sustainability and implement a net zero system. So we chose EcoArt, and EcoArt is an interactive piece of art to generate energy. It utilizes the Triboelectric Effect, and it stores the energy into a battery bank.
Our product imitates a punching bag. You can punch it, push it, pull it, hug it, do whatever, because it has a durable foam exterior that surrounds a plastic casing. It utilizes dynamic instability to oscillate, which converts mechanical energy to electricity.
Yeah, so this is the inner working mechanism of our product. The way it works is sort of like a piston. We have one tube going inside of the other tube, and it's attached to a spring which converts this oscillatory motion into a 1D motion, allowing these two tubes to interact. So just a quick explanation of how the tubes work. We have one tube with a polyamide tape on the outside, and we have another tube with aluminum tape on the inside. As these two oscillate together, we're allowing these polyamide tape to interact with the aluminum tape, and that friction is causing the electrical energy to be generated. And so this is just a quick example of how it works. As you can see, we only used a few pieces of aluminum, and we were able to generate almost 30 volts of electricity. Through our research, we found that in a more optimized scenario, a 5 by 5 centimeter strip of this material will generate enough electricity to power a lithium-ion battery.
So what is the triboelectric effect? Essentially, it's the electrical charging of two materials by rubbing them together. We're harvesting electrical energy by polarizing a dielectric and causing a flow of current through our circuit.
So this is our energy storage system. We would like to implement inductors as well as a rectifier to push the current into the battery storage system. We would like to use a battery bank, which could be scalable according to the customer's needs.
So a little bit of our brainstorming through this process. So we looked at energies that was wasted in the home, and so the top 3 was lighting, HVAC systems, and phantom energy. Of course, in our system, we would like to offset traditional energy and punch us towards a sustainable future. So for our design and looking at the needs statement, we decided to come up with some requirements. So the first one was to harvest clean energy, to store that energy, to make whatever we make durable. We also wanted to make it interactive and fun. Of course, we want to make it cost-effective and have the opportunity to use recycled materials. And most importantly to us, we wanted to educate people on the triboelectric effect. So for our first design, we came up with a piezoelectric floor mat. So basically how it works is you step on the floor mat and that creates energy that's stored into a generator. Unfortunately, for us, this idea was already made. So we went on to our current idea. This presented with a couple iterations. The first was a pulley system, and the second was a layered tube using the triboelectric effect.
So why triboelectricity? There's a reason triboelectricity, and more specifically triboelectric energy harvesting, has been a topic of research in recent years. For one, it's inexpensive. Two, it's a simple mechanical to electrical conversion system. It's also scalable down to the nanoscale. It's very sustainable due to its low cost and durable materials. It can be low maintenance if made correctly, and it has a moderate to high conversion rate, which makes it very effective for its cost.
So here are some reasons why we chose this design. Triboelectric nanogeneration is a novel idea in energy harvesting. Our design would be aesthetically pleasing, so this would draw in younger generations to post on social media. It would generate clean energy to offset some carbon emissions. It's a very marketable idea, so we could place these units in offices, college campuses, homes, and apartment complexes, and we're providing energy in a place that is not utilized. So here's some rough cost estimates. As you can see, our unit would be much less expensive than alternative energy sources that exist today.
So for our future work, we'd like to optimize our system to make it more efficient and cost-effective by utilizing current research and experiments. We'd like to also figure out how to direct our stored energy to more critical systems based off the user preference. We would hope to add passive energy generation to our system, seen here on the slide, such as wind. We'd also like to create more outer shell designs that could aid with marketing, such as using it for ad space, or more specifically, for our school, we'd like to add the rival team's mascot, using student interaction to power their electronics. So these are our resources, and remember,
do your part with eco art.